Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 47. And we have two topics this week that are related but not the same, discrete and different in their own ways. One is the topic of async IO. So async IO is kind of brand new to Python, and it gives you the ability to do multiple things at once but on a single thread. One of the things that's important with async IO is you need to have packages if you're using them to do networking stuff or IO stuff that support async IO. Some networking stuff does, some doesn't, so you need to be aware of that. So over here we'll talk about how it is a single thread, how it requires support for your underlying packages. We will look at async IO code that does host monitoring. And then the second thing that we're going to do is we're going to look at how easy it is to move our quokka application that we created using Flask and Mongo, this stuff that you see right up here, and make those monitoring applications use a form of concurrency. And the concurrency that we'll be using is thread pools, because that's universally applicable to everything that we're doing, whether it's a service or a device or a host. And so that's what we're going to be talking about. Yeah, just as a heads up, I'm going to give you a little tiny teaser about replacing all this cool terminal-based user interface stuff with an actual GUI, a web browser-based user interface that I've been working on and that I'll be teaching about next time. So I'll give you a little bit of a teaser of that as well. Anyway, let's start talking about async IO and concurrency in our quokka application. Okay, so let's talk about async IO. Now, in this lesson, or at least the part on async IO, I'm going to go over a few things. Number one, here's the results of my little async IO program. You can see that it is roughly the same as using threads or a thread pool with a significantly sized thread pool. Here I even have 26 hosts. It still only takes 3.2 seconds, and doing all of them takes 34.3 or so. So you can see that the results are roughly the same as when I did threads. I am going to talk a little bit about the theory. I am going to talk about comparing the actual code. So I'm going to get into all of these things, but it could be a very complicated and deep and sometimes confusing topic. So I'm going to go at a relatively high level at like the 10,000 foot view and then drill our way down a little bit just so you have a general idea. First though, I did want to look at this slide. I created a slide just for async IO. As you can see here, I've modified this picture just to remind ourselves. Our picture of using threads looks something like this, where every one of these was an individual thread. I mentioned there's different ways of doing this, using threads or thread pool or using async IO. This situation is kind of meant to represent threads. If we go down to the new slide that I just created a moment ago, I'm trying to show via this box that is enclosing all of these little smaller rectangles that there is only one thread. And these are little segments of execution that are doing the I/O that we are requesting, but they are using functionality that is called coroutines in order to allow other of these I/O pieces of functionality. I'm trying to avoid the word threads or processes in a general sense because it will be confusing, because they aren't technically threads. They're just functions or workers or instances of execution or whatever you want to call them, but they all are allowed to run, and they are kind of cooperatively allowing each other to run in this situation. And as you can see from the results are quite good. We've reduced this by an order of magnitude by like 10 times, and I suspect we have 26 hosts. I think when I recorded the last thing we had 23. Even if I had 100 hosts, this using async IO probably would stay at 3.2, and this number here would go up just as it would for threads. So you get the idea. There's a lot of benefit to doing something like this when you have I/O bound work like we do in the networking world, or if you are not in the networking world, if you need to do I/O. So there's a few things that I want you to understand here. You may have read ahead because you got bored of me talking about it. My apologies. Much of this you may not understand. If you're an advanced developer, you probably understand what I'm talking about. I want to put these words into your head, though. We can all understand this. It is only a single thread, so it doesn't suffer from situations where you're going to run out of threads. If you have 100,000 devices that you're trying to ping, you should be able to do that. Actually, I don't know that that's 100% for certain, because there may be I/O limitations in your system, so it may start to bog down a little bit, but the threading limitation is no longer there, so you don't have to worry about that, and you don't have to figure out the appropriate thread pool size. Now, this is really critical, so pay attention to this. Requires support by the underlying packages. What do I mean by that? I mean that if you are going to use async I/O, the I/O that you want to use better support this async I/O functionality, this name of async I/O in Python. And I can tell you that NetMiko, Paramiko, Napalm, these packages do not support async I/O at the point of this recording, or at least as far as I could find out from everything that I looked at online. So the networking stuff that we tend to use as network developers, it doesn't work. However, doing something like a ping, as the examples I've shown you, is supported, and I'll show you in the code how it does that. Now, if you're more interested in this, and if you're a new person, you can just put these words in the back of your mind. It's not going to be critical that you understand them. There's functionality called coroutines that has been around as long as I have. In fact, it was first mentioned in 1958, which gives you an idea of how old and ancient I am. But they've been around forever. The general idea back then was that you would have two threads of execution, or two applications running, and they would depend on each other, and they would cooperatively allow the other one to run for a while when they had to wait for something. And so it would go, these two processes would go back and forth, and so you would be able to get things done. That's the idea of coroutines. When you think about that, you think of two, and that was kind of the general idea. So the whole coroutine idea, of course, has evolved significantly since then, but this is the underlying computer science concept. And this async/await pattern, you can look that up in Wikipedia as well. All these things you can look up in Wikipedia. That's the implementation of this functionality that has been done in Python, and also has been done in a number of other programming languages. So if you are interested from a computer science point of view, you can certainly look that up. Now, I do want to tell you this, because we have gone over the idea of generators. Remember generators? I'm going to see if I can do this. Back in M01B intermediate, L12 generators, we saw generators, and we actually did a yield. We may look at that. I may have us poke our noses at that. That type of functionality where you're in the middle of a function, and then you say whoop, yield, and that causes you to stop execution at that point, and then at some later point in time you pick up right where you were. We used it for iterating through these network devices that we were creating, and it allowed us to deal with super huge lists in a manageable way. And it wasn't really necessary for us, but people have asked about it, and good to know. Certainly in data science, it's important to know something like this. The general idea is similar because of the fact that your program is running, and in the middle of running, you say yield effectively. You don't have to write this, but this is what happens under the covers, is your process. In this situation, it's when it's doing I/O, it's going to yield control and allow other stuff to run. And when it comes back, it's going to resume right from where it was. And so, yeah, that is the general idea of what is happening under the covers. It's not actually using these exact things, but that is a general idea. And you can look it up online. I looked online to say what actually happens to cause async IO to work in Python, and you can find a number of discussions of that if you are interested. Okay, so that's the high-level overview. Now let's actually look at the code. So we're about to look at the code. Before I do that, let me just run this over here. So let me run host monitor async IO, and when I run it, you're going to see, bam, just like before, all of these finished really fast. These other ones that were taking a while because they were going to time out took them a while, but eventually 3.2 seconds, you can see that happened. Now I'm doing it the old way, which is doing them one at a time, and you can see that gradually goes on until it reaches the end. So we don't need to watch that till the end. Let's start to look at the code. And there is one thing I wanted to mention. So this generators thing, I did notice that because of the way that I moved things around, I had messed up this import in this particular lesson, in actually this particular code and one other. I can't remember which one. I think it might have been tuples. And so I fixed that up and I did push it out. So if you are prone to pulling down the latest from Python 52 weeks, you can do that, and these will be fixed in case that is a concern to you. But let's go back to our host monitor async IO. The first thing that I'm going to do is a super high level view. All right, so this is the 10,000 foot view, and let's look at what we have. Now the first thing that you'll notice is what I've highlighted here. This is thread pool example. This is async IO. And let's see what's different. Well, the first thing that's different is, remember, over here in the thread pool world, we just used ping host. It was exactly the same function that we had before. All we were doing is we were pointing a newly created thread at this function, and it used this function to execute the thread. In our situation with async IO, I need to create a brand new function, and that's because of what I'm doing inside it and the way that I declare it. And remember, we're doing a 10,000 foot view, so I'm not going to go into the detail of this, but if you were to look, you can see, oh, there's a new keyword, async, in front of the definition of it. And the actual, if you were to have an eagle eye, over here I did subprocess. Over here I have to do async IO.create subprocess exec, and then I pass stuff in. And then I'm doing my own thing down here. All right, that's the first thing to notice. Now you'll see that I have ping host. That's because I'm doing this comparison. Remember, I need to have ping host so that I can do this comparison. That's why ping host is there in that situation. So let's look at our main functionality. So over here in async IO, here is my main function, and this is the interesting bit right here. And over here is my main function using thread pools. Now the first thing you'll notice is over here, my main, let me try to line these up so they look more the same. Over here, my main is just normal. Over here, guess what? I need to identify to Python that this is an async function. So everything that you have down your thread of called functions, you need to identify as being an async capable function. So even though I'm just doing things kind of normally like I did before, I need to identify it as async. Now the next thing you'll see that's different, ping using thread pool, is those two lines, and ping using async IO. The good news is I've made it really simple. Just like with thread pool, there is a whole lot of confusing stuff online, and I was able to simplify it to doing something like this. In our situation with async IO, I was able to do something similar as well. Now you can see it's a little bit complicated. We'll get into that in just a second. Now the last thing to notice is our call to main. What's so special about that? The answer is absolutely nothing. But wait, there is something that's special about this. I'm calling async IO.run, and I'm passing in this function main, and that's what I need to do to get the whole process going. So a lot of new things compared to what we had to deal with threads. But let's begin to dive down into these in more detail, and I will pull this back up and we'll get rid of our host monitor thread pool so we can just look at this. So here we are looking at async IO. First thing is we call main. Main is going to be an async process, and it's defined as such, async def main. And the new code in here is this. So let's pick this apart one line at a time. Ping host equals, hang on to your hats here. What is this? This is going to be, remember what we call this? This is a list comprehension. But this is probably a list comprehension like you haven't seen before. This part here is going to look pretty familiar. So I'm basically going to iterate through host.values. Remember, hosts is a dictionary of dictionaries. Every host is a dictionary, and my thing called hosts, which I got back from the discovery process, which I also get back from doing when I call, let's see, where do I call it? I call get hosts. That gives me these hosts. That's going to be a dictionary of dictionaries. If I want to turn that into a list of dictionaries, I can get just their values. And since the key is actually duplicated both in the key and as a value, the key is host name, remember, but in the host dictionary, it has a field called host name. I'm perfectly okay doing this so I don't lose any important data. So I'm going to go through every host in this. And what am I going to do with it? Well, this is where it's a little bit different. So what I'm doing with it is I'm basically saying ping host async. What is that? Well, remember, ping host async is a function. So this is, I'm identifying this particular function, and I'm telling Python, I want you to create items in my list that are going to be calls to ping host async. And guess what? I'm able to pass in the parameter that I'm passing in, which is this host value. So at the end of this, my ping host is going to be a list of function calls that are going to be calls to ping host async. And why am I doing that? Why would I ever do something like that? Well, the reason is because when I'm going to begin to do all of my async IO stuff, then what I need to do, I'm going to call this gather method, and what I'm passing in is going to be this list. Although remember, I've got a star here. Remember, we have keyword arguments and we just have regular arguments, and this is going to turn my list into regular arguments, and I'm passing those in together. So this would be as if I typed in async ping host async host1 comma ping host async parentheses host2 comma. If you look up online and look at asyncio.gather, you'll see examples where they actually put all like 3 different functions that they're going to be calling in a row separated by commas. I'm doing this as a list, and the way that I turn that list into parameters that get passed, actually functions with parameters. Well, I'm turning them into parameters that get passed together. And what are the parameters? Every parameter is this function and a separate host. So for every host, I'm going to be calling it. So basically, if I have 26 hosts, it's going to be calling ping host async 26 different times via this call to async gather. Now, how does that actually work? It works because ping host async is, guess what? It is an async defined function. So it is basically playing the whole async IO game. And what does that mean? What it means is that it's going to begin to execute this, and this is the main thing that you need to be aware of. This is how async IO waits. It's cooperative multitasking in the sense that you need to call something to allow your I'm going to use the word thread. It's not a thread, but your instance of execution, in order to cause your instance of execution to give away control of your process and let other things run, or your thread and let other things run, you need to call things with this await keyword. So this await keyword right here I've set up my ping command. That's the same as I've done before. And here I'm basically calling into that same subprocess function that we were doing before. In fact, why don't I go ahead and bring this up, and I'm going to put it to the right. I shouldn't have gotten rid of that split right. There we go. Let's look at what we were doing with the ping before. Our ping host, we called subprocess check output, and we passed in all of this stuff. I'm not going to go through all the details of what exactly that is, but that is how our ping worked. And basically what we're doing in this situation, here is my host monitor async IO. What I'm basically doing is exactly the same thing. My ping command is right here. That looks exactly like this one did here. And I'm passing it in, and I'm using again this star, which will cause this list to become a bunch of parameters that get passed in. And I'm pushing the standard out to the subprocess async IO subprocess pipe. I'm not caring too much about that right now. All I care is whether it works or not. And then the next thing I need to do is I need to, once it has started that process, then I need it to go and wait until it completes. And I do that by calling that process.communicate. And that will cause me to wait until it's done. And I will get back standard out and standard error. And the only thing that I saw that was of use in this situation is standard out. So if I get something back from standard out that says 0 packets were received, then I know that it failed, and I'm looking basically at ping output. Remember, if you do a ping from a terminal window, then you will be getting back something that will say 3 packets sent, 3 packets received, or whatever. And if you're getting nothing back, then it will tell you that 0 packets have been received. And that tells me that this has failed, and I set availability to false, and I print this out. Now, I'm not doing anything with my host availability in these little applications to point it out, so I don't really have to do that, but I do print this. Remember, we're looking at this, and I say host ping failed, etc. And if it worked, then what I'm going to do is I'm just going to print out, and this is the important thing here, I'm going to print out that it was successful. And this catches if there was an error. I haven't seen this particular error. I don't think this is a little bit unhelpful, though, that I just do this here. I believe that what I end up hitting, and I can't remember, is this one right here, is my 0 received. I don't know that I ever hit this one. And so that is what my ping host async is going to do. Did that make sense? So basically, I'm creating a list of these function calls, which are going to be ping host async with host 1, and then with host 2 and host 3, host 4, etc. in my list of hosts. I get those together, and then I call gather, and that is going to actually go and begin these things one at a time. And because it's an async process, then it's going to just execute until it sees this await keyword, and then it's going to allow other stuff to run. So when you do this await, then it will allow other things to run. I played around with this. I guess what I need to do is I need to do an await here in order for it to return something called process, which is then effectively awaitable. And you can see I'm calling into async IO create subprocess exec. What that says is that this subprocess functionality, which is normal part of Python that we do to do various things, is async IO ready, and it's awaitable. So you're able to do that. In our Napalm or NetMiko or Paramiko example, those have not been modified to support async IO, and therefore I cannot do the same thing with them as I write this today, as far as I can determine using async IO. Now that may change by the time you hear this. It may be that I've looked in vain and actually it's supported in a brand new version that I'm not aware of, but as far as I know at this point in time, it's not supported, and you are dependent on it being supported for whatever functionality you want to do. So it's not entirely in your control to say, you know what, I'm going to use async IO. What you have to say first is you have to say, let's find out if the things that I'm using that do quote unquote IO are awaitable. And if they are, then yes, you can use async IO. And if they are not, then no, you cannot use it. So hopefully that has given you a general idea. Let's just review really quick. When I run it, I need to do asyncio.run. When I'm actually creating it, what I'm going to be doing is I'm going to call await asyncio.gather, and I'm going to pass in the function that I want to call with the appropriate parameters. And remember, I also, in my function that I'm running, I need to have the async keyword here. Then in the function that I'm calling, what I need to do, oops, that's the other one. This is my async one. I need to identify it as async, and then I need to use async IO functions to do the things I want to do, and I need to put this await keyword in front of it. So this is the thing that needs to support it. If it supports it, then I can say process equals await, and then I can say await process.communicate, and that will allow everybody to share things. And let's go back to this picture, and that allows this magic to happen. And this is basically all using the same thread, and that magic is what allows basically this right here to happen. Everything, when we ran it, it happened really fast, and it's amazing. I should be able to do some, hundreds of these or whatever. I have no idea if there's limitations on that, but yeah, and it goes really, really fast. So hopefully that is a good enough explanation so you have a general idea. Oh, and I just want to review this. As long as we mention it, I'm going to review it in my last bit at the end, but I did want you to be aware we are using a single thread. It does require support. I've mentioned that. I didn't go down into coroutines and async await because that's a computer science-y type thing. And then we did talk about how internally it's implemented using some yield type functionality, and I didn't go into that at all. So now we're going to talk about how I've implemented concurrency in our Quokka application. Remember, our Quokka app is monitoring devices and hosts and services in my network. The hosts are in my network. The services obviously are not in my network, or at least most of them aren't. They are located elsewhere, but I'm monitoring them for DNS servers and HTTPS, NTP, etc. I just opened up my own device. This is the one thing that's actually in my network of these things. Well, and I guess my gateway is too. This one here should turn turn green, or it should turn this cyan color once it is alive and able to communicate, and the ping goes through communicating with it. So we'll see that happen. This embarrassingly took longer than expected, so I sped it up. Okay, there, it finally appeared. Not sure why it took so long, but anyway, you get the idea. That's what the application's doing. Remember, we built the central point of the application on Flask. I'm using Mongo as a backend, and I have this application here that actually is 4 different applications. There's a device monitor, there's a host monitor, there's a host scanner that's giving me this type of information, and there's a service monitor. And so these are out there going about their business. They are calling into my Flask server in order to get the information updated. And then these particular applications that are running here that you see, these are just pulling the data out of the Flask service. And so I have a number of things running and doing stuff. And what I decided to do was to change each of these services that's running and doing the monitoring to actually use concurrency of some type. And the question is, how difficult would it be to do that? And that's what I'm about to show you. And the answer is not very difficult at all. So here is my device monitor code. This is my main application. You'll recall I go out, I'm doing discovery periodically. There's a bunch of other stuff going on, but when I do get the devices, I'm going to go and do get device facts. That's using napalm. And so I'm going to go and do that for every device. And then I update the device. This is actually the more involved implementation that I did. So let's look at what I did in my concurrency version. This is my older version, M07. This is my newer version, M08. What did I do? Well, I'm using a thread pool executor. I'm passing in the thread pool size, so I read that as a command line argument, and I have a default value of 8 or 10 or something like that. So I have these thread pools set up with a bunch of workers, and then all I need to do is call executor.map. So this thing here is executor, is the executor that I created. And then I have to do call.map. And remember what I do is I point it at the function that it will be using. So this is the code that it's going to be using. If I do a control B, this takes me to get device facts. This has not changed at all. It's exactly the same as the way that it was before. Well, almost exactly the same. What map does is as I give it a function, and map is a general type of functionality that's available in a number of languages. And what you do is you pass in a function name, and then you pass in a list of parameters or attributes that you want to pass to it. And for me, that list of parameters that I'm giving it is devices.values. So that is actually a list of my devices, and it's going to call get device facts. Now, if you look over here, I called get device facts for every device. I'm doing exactly the same thing, devices.values. I'm just iterating through it. If I could have, there's actually a map functionality that's available in Python. I could have done exactly this with Python. But so you notice I'm calling get device facts for every device, and then I'm calling update device. Well, I wanted to simplify that. So if you've peeked a little bit above, you can see this update device is present here. And I haven't showed you what this functionality is right here, but this is exactly the same functionality. It is my get device facts. And at the very end of this, I'm calling update device. So here is my get device facts. And once I've done that, I'm calling update device. In the previous version, I called get device facts, and when I was done, I just returned and I allowed update device to happen here. In my situation down here, because I'm doing this separate thread for everything, I just decided to move update device into this function. And so that is my version for devices. Let's look at what happens when I do this for hosts. Here's my host monitor, and this is the old version of host monitor. And here's my host monitor. This is the new version. I'm going to take the old one so that it's always on the right, and I'm going to move it to the right. And here is my main. This is the functionality that we're looking at. Let me go down here to main, and this is the functionality that we're looking at here. So let me line this up so it's a little easier to see exactly. Over here I do get hosts. Over here I do get hosts. Let me go right here. This is the way I did it before. For host in host.values, ping host. And the equivalent over here is with thread pool executor as executor, executor.map. That should sound familiar. But the function that I'm using, the code that it's executing is ping host. And what's the list of things that I'm doing? Host.values. That's exactly the same thing as I had here. Oh, and once again, if I give you a sneak peek at what the code looked like before, I had this code right there. You can kind of see before, at the end of my ping host, I did nothing, so I needed to do my update host in my loop. In this situation, I changed to make sure that I just updated my host directly in ping host so that I didn't have anything to do. So we're comparing this code here to this code right here. And this is all I had to do. And that was my hosts. Let's go to my services. Service monitor, this is in the concurrency one, and service monitor here is my other one. I'm going to push this one and split it to the right. And then over here I'm going to highlight my M08 concurrency service monitor versus M07 service monitor. So let's see what this looks like. Let me go down here. I haven't actually looked at this. Here's my main. Here's the code that I'm actually calling executor.map and I'm calling get service status, and I'm passing in service values. In my situation over here, I call get services as I do over here. And then I go through all of my services. I get services.values. I had something a little bit different, so I did something a little bit different. Get service status, I used to return true or false, and it would only update the service if I got the service successfully. What I did was I pushed that into the functionality that I have right here. And once again, I do update service over there. Over here, I returned true or I returned false, and I just changed the logic a little bit. Maybe this one had a little bit more code for me to write in order to get rid of that. So this is the M07. I did this. This is my M08 concurrency. I did this right here, and I just changed to have update service in this call. Everything else is exactly the same. So if you're looking at that and saying, wow, that looks exceptionally simple, I can tell you that it was. It helped that I had gone through this in our code examples so that I knew exactly what I was dealing with. Let's get rid of this. Let's get rid of this. Let's close that up. It helped that I had gone through this and I had simplified things as much as possible so that I saw that all I needed to do in order to get my thread pool thing to work was this. Once I had figured that out, then applying it to my M08 concurrency quokka became very easy. Let me get rid of the user interface stuff that I'm also working on. Whoops. There. And so here you can see it's just exactly the same code that I had before. I moved everything together. I don't have a common directory, so everything is located together. I had to do, of course, when I went through my device monitor, I had to do things like, let's see, this device monitor is the common one, so I don't want that one. Here's let me go to the service monitor. We'll look at that one. You can see that I had to do this import of thread pool executor, and I needed to add argument parser. I had to do that in all of my different versions. So I had to do that for services, I had to do that for devices, and I had to do it for hosts. And once I did that, that was a little bit of extra code that I had to add. But the main functionality that is important to you guys and to me is this line, these two lines of code right here that actually does my launching of the threads and then waiting for the execution of the threads to finish. Now, you will be in situations possibly in your life where threads are more difficult. I don't want to make it seem super easy, but in my situation, I'm definitely able to live by my adage, everything should be as simple as possible, but no simpler. So I was able to make this extremely simple such that the modification did take me less than 10 minutes to do all of this, to migrate it from a single thread doing the polling to doing multiple threads, and so that everything happens at once and my output looks nice and slick. So that's how I did it, and hopefully you'll be able to do something similar if or when you choose to implement threading in whatever application you may choose to do. So hey, before I do my wrap up for this session on async IO and on doing concurrency in the quokka monitoring applications, I just wanted to tease you with a little bit of a view of the GUI that I built on top of our little mini quokka application. This is using React, which is from Facebook, and Material UI, which is from Google. So those frameworks are useful for creating both the ability to do this as well as the look and feel of the table. I'm using other stuff as well. There's not a ton of it, but I wanted to just let you know that we will be going over this, I think, in the next set of lessons to give you an idea of what the code is all about. I'm in WebStorm. This is actually, you have to pay for it. It's by the same people that do PyCharm. You buy it per year, and it's like, I can't remember if it was $199 or something like that. I went ahead and bought it because I didn't have any experience whatsoever in building user interface code. Perhaps, as you can see, it turned out okay, but I was inexperienced in the new world of building everything within a browser and with these frameworks. Just to give you an idea, this is the main launch point, this thing called index, and then we create a component called dashboard. I can do Control B to dive down into dashboard. Here's my dashboard. You can see it's basically going to be the thing that you see at the top there, the dashboard that's in blue. And when we look at it, you can probably see that, okay, there's going to be something to show the devices, hosts, or services, and that matches up with what we see there, devices, hosts, services. And then for each one of those, I will be launching something. So if I was to just go down into the hosts for a second, you can see there's a fair amount of stuff that I'm importing. I have a countdown timer. I am going out and fetching information from the server. So that's what I call fetch host, and this is how I do a URL request. We'll have to talk about this when we get there. But then there's this HTML/JavaScript code combination that's part of the frameworks that I'm using, and that is what allows me to render the tables. There's also another third-party thing called Material Table that I use to give me a lot of the table type functionality of sorting based on various things, as well as pagination and search. And so that's kind of it. Just wanted to tease you with it. We will learn about this in the last lesson or two. It's not Python, but it might be useful to you to know how to do a little bit of front-end stuff. If you do augment your skill set to know about front-end, then with your knowledge of front-end and web service and business logic and back-end database, you could call yourself a full-stack programmer. And that is something that people are looking for and is in very high demand. And even if you don't go out and try to get a job that's in that, having the ability to do that will make you of much more value to the company that you do work for. So that's just a tease of what's coming in the future. Now we'll go to the review. Okay, folks, let's review what we talked about in this lesson. Remember, we were talking about a couple of things. One was async IO, and the second was the incorporation of concurrency in the form of thread pools into our quokka application. And so that is what you see right here. So let's start at the top. We discussed visually what is going on with async IO. I modified this picture a little bit to show that everything is running in one thread. That's the larger, darker rectangle. All these little instances are really bits of functionality that are running inside the same thread. So remember that it's running inside the same thread. One thing that I pointed out that's very important to remember is that in order to use async IO, it's not just your choice, but the package that you use to do IO. If you're a networking person, that might be Napalm or NetMiko or Paramico or something of the sort. That will need to support async IO in Python, and many of them don't. In fact, Napalm and NetMiko, etc., do not at this time. So you do need to be aware of that. A couple of the things that are more computer sciencey in nature, you don't have to worry about these for writing the code, but we have coroutines going on, async await pattern, and then the internal implementation actually has some functionality that is similar to what you get with yield when we talk about generators, which we did a while back. So that's visually what we were talking about. Now, if we go into the code and look at that, then If we were to go to async IO, that's what this is. We're going to walk through the code. I'm going to just do it from top to bottom, maybe mix it up a little bit so that you are able to learn it in a little bit different fashion and hopefully make it stick a little bit more. So this is our function. We had to rewrite our ping host function. This is the old one, and this is the new one. I called it ping host async. It has an async qualifier or keyword in front of it. That tells Python that there's some async type stuff going on. And as you won't be surprised to know that since it's the async await pattern, that there are await keywords that are used. One thing you need to be aware of is instead of just calling create subprocess as we did down here with subprocess checking the output, we need to have a whole new function. And so within the async IO library, they give you the ability to create a subprocess and execute it. And so we pass in the ping command, and we have an await keyword here when we create it. And this process that was created during that function, we can then do an await on it and wait until it completes. And the general idea is that a whole bunch of these will be started, in fact, one for every one of our hosts, and they will run effectively simultaneously. And so we have to do a little bit different test to know if it worked because we don't have the ability to have exceptions thrown in the same way. And so we're looking at the actual standard out to see if no packets were received, then we say up, availability is false. And that is the ping host async. If we go down a little bit further into our main program, you'll notice, hey, there's a keyword here called async in front of it. You need to have that during the entire set of functions that are going to be using this async IO functionality. The actual code here is very similar to what we had before. In fact, it's very similar to the thread pool in the fact that there are two lines of code here that we're going to use. Now, this is a little bit more difficult to parse. Look at the code. Look at my explanation of this to get the details, but we have a list comprehension where we're putting into the list function calls for our ping host async function, and we're passing in the host. So we iterate through all of the hosts. We pass this in, and this is how we launch all of our async functionality. So we're pointing at this thing, which is the actual function. Remember, ping host async is the name of that function, and then we're passing in the parameter host, and this is where we call it and we wait for it to finish. We do a gather using the async IO library, and that will cause us to wait until all of these have completed. And we did look at the output. I'm not going to look at that right now, but the output looks very similar to the output that we had with threads and thread pools. And the last thing to note in terms of the code here was that for our main function, when we call it, we need to call it with this asyncio.run in order to run our main function. The other thing that we went through was a demonstration of how easy it is to add concurrency to our current Quokka Flask project. So what I did was I took this common and Flask Mongo Quokka, I put it together into this directory here, called it concurrency Quokka, and all I did was I went through device monitor and host monitor and service monitor, and I modified it to use concurrency. Now the concurrency that I used, because it is easy to do and works with all three methods, all three of these applications, is to use thread pools. So I did thread pool executor. Remember, we talked about that in the last lesson. You can go remind yourself of that. But basically, this is exactly the same code that I had in that particular code right up here that you see. I just create my thread pool executor object. I call it executor, and then I call executor.map. Remember what map does? And map is something that is common as a way to iterate through a number of things. So we haven't gone into that in great detail, but I did describe it back when we were talking about thread pool especially, and that is that you pass in a function and then you pass in a list of values effectively that will be passed in. So you're going to iterate through all of these services and you're going to call get service status every time. What does get service status does? Well, it's exactly what it was before. I didn't have to change this at all. except I made it easier by doing update service at the end of it. So I made this code a little bit simpler. And if you look at device monitor, it's exactly the same thing, changing update device. And if you look at host monitor, again, it's exactly the same thing. The only thing that you'll notice here is I do have something called thread pool size. Where does that come from? Well, I modified all of these so that they would actually have a parameter that could be passed, and I would grab the argument called pool size and use that as my thread pool size. And that was all I needed to do. As I mentioned, it took less than 10 minutes, and magically I have this wonderful code that now does concurrency for all of its monitoring, which is a good thing. I need to add that to the real quokka project, but I haven't been there in a while, so I'll have to look at that. Anyway, I hope that makes async IO a little bit clearer, and I hope it shows you how easy it can be to use threading in an application where you have IO bound functionality like we do when we're monitoring devices or hosts or services or whatever it might be. In fact, in my situation, I realized I did it to port scan as well. So port scan, I actually have my thread pool executor here with my port scan. So there you go. Hope that made sense. If not, as always, please contact me with your questions. I'm happy to help. Until next time, thanks for listening.